press the brake pedal to stop your car. That is what every driving instructor on Earth taught you, and you have done it tens of thousands of times without thinking. The average American driver pays $600 to $1,200 for a full brake job, and they repeat that bill every 40,000 miles for the life of the vehicle. Then you read a Prius Club Facebook poll of original owners, and the numbers stop making sense. 60% report their factory brake pads have lasted past 100,000 miles. 20% report past 200,000 miles. 6% are sitting somewhere between 160,000 and 200,000 miles on the original set. Same brand of pads, same physical hardware, triple the lifespan, they are all using the same button. It is on the gear selector of every Toyota hybrid sold in the United States since 2001, and 99% of hybrid drivers have never pressed it on purpose. Toyota engineers built it. Your dealer never explained it. Across the lifetime of one car, ignoring it costs the average owner over $5,000 in brake jobs that did not need to happen. There is also one situation where pressing this button at the wrong moment can damage your transmission. The rule that prevents that is coming up. Stay until we get there. Quick disclaimer before we start, the tips and guides in this video are for educational purposes only. Every vehicle is different, so please use this information at your own risk. We are not responsible for any damage or injury that may occur. When in doubt, always consult a professional mechanic. If you drive a Prius, RAV4 hybrid, Camry hybrid, Corolla hybrid, or any Lexus hybrid, look at your gear selector right now. There is a B position sitting next to D, and you have probably noticed it for years. Here is what most drivers experience. They accidentally shift into B once at a red light, feel the car lurch when they lift off the brake, and panic back into D. From that moment on, B becomes the position they avoid. The dealer who sold you the car had 8 to 10 minutes during handover. They covered the touchscreen, the cruise control, the phone pairing. They did not cover B mode. The owner's manual mentions it, but the entry sits buried under towing instructions, where most drivers will never look. Industry technicians who service hybrids report something specific. It is common to see Toyota hybrids at 70,000 to 100,000 miles still running their original front brake pads. That observation comes from professional brake specialists writing in industry trade publications, not from internet forums. The pads simply outlive the wear curve a conventional car teaches you to expect. 2 to 3 times the brake life of a comparable gas car. Invisible to most owners. Invisible to most dealers. And the engineering reason for it is sitting one shift position away from where your hand rests. But original brake pads at 100,000 miles is not the ceiling. There is a group of drivers using B mode on the right roads who double even that number, and the data we are about to look at is the part your dealer would never volunteer. Here is what changes everything. The Kelley Blue Book industry baseline for brake pad lifespan on a conventional gas vehicle is 40,000 miles. The Prius Club poll numbers 60% past 100,000. 20% past 200,000, 6% sitting between 160,000 and 200,000 are not outliers. They are the new baseline for a hybrid driven the way Toyota engineered it. Run the math against any conventional car. A gas vehicle owner replaces brake pads 4 to 5 times across 200,000 miles of ownership. A hybrid owner using the system correctly replaces them once, sometimes never. Here is where the skeptic in you might object. Of course, hybrids last longer, the regenerative braking does the work. You don't need a special button for that. And you would be partly right. Cross-reference the Prius forum threads where drivers report 200,000-mile pads, and one trait shows up over and over. They drive in hilly or mountainous terrain, and they engage B mode on every descent. The drivers reporting standard hybrid brake life 80,000 to 100,000 miles drive, flat suburban routes, and have never used B at all. Same vehicle, same regenerative system, different button habit, double the brake life. Now, let me explain what is actually happening under the floor. Your hybrid has 2 motor generators, called MG1 and MG2, connected through a planetary gear set. Lift your foot off the accelerator in D, and one of those motors resists driveline rotation, generates electricity, and sends it back to the high-voltage battery. That is standard regenerative braking. Lift your foot off the accelerator in B, and that resistance amplifies significantly. Toyota technical analysis of the system shows recharge current jumps to 30 to 40 amps, the highest sustained recharge rate the hybrid system can produce. And here is the part most drivers find hard to believe. On a 2001 to 2004 Prius, the hydraulic brake pads only physically engage when the vehicle drops below 7 miles per hour or in a panic stop. The other 99% of your braking is happening through the motor and the engine, not the pads. The pads on those cars often outlive the original owner because the pads barely move. But if B-Mode is doing all this work, why does Toyota's own owner's manual warn that you should not use it on flat roads? And why does the manual say that misusing it can damage your transmission? To understand why this matters, drive in a taxi in Tokyo for 10 minutes. The vehicle you are sitting in is most likely a Toyota Crown Comfort or its replacement, the JPN Taxi. The Crown Comfort ran in continuous production from 1995 to 2018, 22 years of the same car serving as the backbone of Japan's taxi industry. Roughly 200,000 units were built, and many are still running. Tokyo taxi drivers run 10 to 12-hour shifts, 6 to 7 days a week. The same vehicle accumulates more miles in 2 years than the average American Camry covers in 8. These cars are mechanical truth tellers. Here is where it gets interesting. About 60% of Japan's terrain is mountainous. Daily descents from elevated cities are not the exception in Japan. They are the standard route. B-Mode was designed for this use case first. The flat suburb American driver was a footnote in Toyota's design specification, not the headline customer, which is why the function feels invisible in Houston and obvious in Hakone. Cross over to Hong Kong, and the pattern repeats. As of January 2026, around 4,000 Comfort hybrid taxis, the LPG hybrid version of the JPN Taxi using Toyota's hybrid Synergy drive, are in active service. Their daily routes include the descents from mid-levels, the Peak, and Stanley. The cars accumulate massive mileage on the same brake hardware year after year. The Hong Kong fleet operators understand exactly what B-Mode does because their margins depend on it. Toyota engineers a global product. Toyota markets toward the dominant local profile. In a Texas dealership, the customer is not driving the Rocky Mountains every morning. The button stays on the gear selector because the engineering is the same worldwide. The explanation stays buried in the manual because the daily benefit is invisible to the buyer in front of the salesperson. Knowing the cultural context is one thing. Knowing exactly when to press B on your specific commute is another. Press it at the wrong moment, and you actually waste fuel and accelerate transmission wear. The protocol matters. Here it is. If you are watching this on your hybrid for the first time and you have already located the B on your gear selector, drop a comment with your make, model, and odometer. Subscribe to Car Care Simplified. Every Tuesday, we break down one Japanese maintenance method your dealer will not volunteer. There are exactly 4 scenarios where B-Mode does measurable work. Outside these scenarios, the button should stay untouched. Memorize the 4, and you are operating your hybrid the way Toyota's engineers intended. Scenario 1 is the highest value use case. Any descent over a 3% grade lasting longer than half a mile. Activate B by shifting from D1 position toward U, the same way you would engage low gear on a manual transmission. The car will decelerate noticeably as you lift your foot from the accelerator. Modulate your speed by feathering the throttle, not the brake pedal. At the base of the descent, shift back to D. This is the use case where 200,000-mile brake pads come from. Scenario 2 is sustained downhill stretches in slow traffic. Daily commute through a city built on a slope. Engage B at the top, hold it through the slow crawl, return to D when the road levels. This prevents brake fade, the dangerous overheating that occurs when conventional brake pads are pulsed against rotors at low speed for too long. Scenario 3 applies if you tow with a hybrid rated for it. RAV4 hybrid and Highlander hybrid both qualify. Engage B on any descent while pulling a trailer load. The supplemental engine braking force significantly reduces brake heat buildup. B-Mode here is a supplement, not a replacement. Watch your brake temperature warnings. If the system flags overheating, the brake pedal still does its primary job. Scenario 4 is the inverse rule. Do not use B mode on wet or icy surfaces. Here is why. B mode operates only on the front wheels through MG2. The rear wheels receive no regen force. A sudden regenerative drag on slick pavement can lock the front wheels in brake traction before vehicle stability control has time to intervene. On bad surfaces, stay in D and modulate the brake pedal gently. The system blends regen and friction more safely that way. Now the warnings. The manual buries. Used permanently, meaning B is your default driving position. Toyota's own owner's manual notes that certain gears in the planetary set may be damaged over time. Used 2 to 4 times a week on real descents, the risk is 0. The transmission damage warning applies only to permanent use, not to daily situational use. On flat highway driving, B costs you 2 to 3% in fuel efficiency because once the battery hits full charge, the engine drag becomes pure heat instead of recovered energy. Press B to brake, press D to drive. Forget you have it on flat roads. That is the entire protocol. Now, run the numbers across the actual life of a vehicle. A conventional gas vehicle owner replacing brake pads on a 40,000-mile cycle hits 5 separate brake jobs between purchase and 200,000 miles. Industry pricing data from AAA, Kelley Blue Book, and Consumer Affairs for 2025 and 2026 puts a typical pad and rotor job at $600 to $1,200 per visit, with simpler vehicles like a Honda Civic running as low as $300 per axle at an independent shop, and luxury vehicles climbing well past $1,500. Even taking the conservative middle, the lifetime brake spend for that ICE driver lands between $3,600 and $5,000. Now, run the same vehicle life on a hybrid driver who actually presses B at the right moments. First brake inspection at 100,000 miles, possibly a partial pad replacement, call it $300 to $600. Full pad replacement somewhere around 200,000 miles, $400 to $800. Total lifetime brake spend, $700 to $1,400. The differential lands between $2,900 and $3,600 per vehicle. A $0 button, $3,000 to $4,000 saved across one car, from a function most owners never press on purpose. Here is where intellectual honesty matters, because the data has limits. What we know with hard numbers is the Prius Club survey reporting, the Kelley Blue Book pricing baselines, and the industry technician observations from trade publications. What we do not have is a controlled scientific study isolating B-mode's specific contribution from general regenerative braking. Toyota service technicians recommend B-mode consistently for descents. Forum data correlates B-mode users with the longest brake life, but a peer-reviewed isolation study quantifying how much of the savings comes from B-mode alone versus standard regen does not exist publicly. That uncertainty does not change the math. Whether your savings is $3,000 or $5,000 over a vehicle's life, the cost of pressing B at the right moment is 0. The cost of not pressing it is measured in brake jobs you did not need. This is not really about a button. It is about the gap between what your car can do and what you have been taught to do with it. Toyota engineers do not assume the driver knows. They build the function. They label it. They trust the curious driver to find it. Western driver education focuses on operating the vehicle, not on understanding the machine you bought. The result is a 25-year-old engineering solution sitting on every hybrid gear selector in America, mostly ignored. B-mode happens to be the most expensive function to ignore in dollar terms. It is not the only one. The real-time fuel consumption display on your trip computer rewards the driver who watches it with measurable mileage gains. The hidden maintenance reset combination lets you clear service codes without a dealer visit. The auto lock at speed setting buried in the menu prevents thousands of stolen items every year, all of them documented in the manual that most owners never open past page 10. Toyota gives you the engineering. Your dealer sells you the service. The space between what you know and what your car can do is where every dollar in unnecessary maintenance lives. The drivers reporting 200,000-mile original brake pads are not better drivers than you. They are not luckier. They read the manual, found the button, and used it on the right roads. That is the entire difference. We started this with a $600 to $1,200 brake job most owners pay every 40,000 miles. We finish with a $0 button most owners never press. The gap between those two numbers is reading what came in the glove box. Next Tuesday, we're covering the second hidden hybrid function that 99% of Toyota owners ignore, the one that doubles your transmission fluid life. Subscribe so you do not miss it. Here is the challenge. Drive your hybrid for 30 days using B mode on every descent over half a mile. At the end of the month, comment your brake pad measurement and odometer reading. Let us see who is already on track for 200,000. Every script, edit, and voiceover on this channel is crafted with real human expertise, not mass-produced content. If this helped you, subscribe for more.